First, a few words about myself. My name is Dan Erez. I work in the high-tech industry for more than 20 years, doing development and later on architecture. And currently, I work as a lead architect in AT&T. And part of my role is assisting the huge modernization effort that AT&T is going through. And I'll talk about that in a little while. I also speak in conferences and write articles, so feel free to check me out on Medium. And today, like I said, we're going to talk about API security and why should we care. Since I'm here, obviously, we do care. And I'll share some war stories about it to emphasize its importance. And sorry. And then I'll talk about some common and uncommon security measures that you can and should uh, use, and a little bit about the future of APIs and API security specifically. So let's start just to make sure we're on the same page. I want to emphasize that when I say API, I'm not just talking about user or browser to a server. I'm talking about all kinds of um, APIs, meaning any endpoint that an application exposes. It can be REST or some other protocols, and anyone can call it. Can be machines, services, browser, and even manually via Postman, for example. So that's what I mean when I say API. And APIs has been around for a long time, mm, more than 20 years, almost 25 years. And just noting that in AT&T we have almost all of these kinds of APIs, from XML to REST and GraphQL. So usually, if you work in an enterprise or a bank or a large company that's been around for a while, you're sure to encounter a few of those. And nowadays, everybody uses API in various forms. And as you can see in those numbers from Gartner and from other research, it's going to get more. People are going to use more APIs. Organizations are going to expose more APIs, and this is going to be risky because if you think about your application as a house, then the APIs are the door and the windows, and obviously any intruder will attempt to go through these first. And you better not keep them as the broken windows you can see in the image here, but keep them uh, whole and safe and with iron bars on top of them. And this is not easy to achieve because truly it's a wide attack surface, but there are a lot of things that you can do, and I'll talk about that as well. Just one more thing about API, it's no longer just an implementation detail. It's now has gone to the design domain, and API first design is getting more and more common. It's close in heart to domain-driven design because an API basically is describing some business service, and it's actually a contract between the application and its users. So it's basically a set of business services, and this idea makes it very easy to develop and very fast to develop application nowadays. Because once you define the needed business flows, you can define the interfaces, and very fast you can implement or even generate the APIs and some mock implementation. And from that moment, you can run the flows without real data, of course, but you can validate the flow. Um, and basically, you have a skeleton of a working application. And once the business people validate it, you can just add in the implementation, or even better, ask Chat GPT to complete the implementation. And recently, I mean, a few weeks back, Postman released Postman flows that enables you to do just that, expose APIs easily, and create a flow and actually build your application fast enough based on APIs. But that's subject for another session maybe. The story in AT&T goes like that. We have tons of application. This is truly a large enterprise, more than 7,000 application, and many of them already went and moved to Azure. Some of them we've rewritten from scratch. Some of them we just modernized, meaning use the same code base but with cloud services, cloud databases, cloud queues, etc. Some were already new and just were lifted and shifted to Azure. But in any case, we introduced a high degree of new connectivity because every application talks to several, sometimes many other applications of the corporation. And once an application moves to Azure, things change, new APIs are introduced, old protocols were upgraded to REST or to GraphQL, and this plethora of new connectivity introduced a lot of risk as well, and we reached a state of what's called API sprawl, meaning that you've got a lot of new stuff, you don't really know what's going on, it's harder to manage, you have a larger attack surface, and it's harder to employ standardization. But we're still on it. This is work in progress, actually. And if you're wondering whether modern APIs are as vulnerable as the old technology used, then I can show you two examples. First of all, T-Mobile working in the same area as AT&T. Not too long ago, right? Up to January this year, they were exposed due to some exposed API. They don't share the exact details, of course, but 37 millions of customer accounts were compromised, which is pretty bad. And Booking.com, famously known online travel agency, were also breached. Accounts were taken over, and that was, I'm not sure if you can see that from my screen, happened in March this year, very recently. So this is definitely an issue. And you better check your Booking.com account to see if there are new trips booked there for someone you don't know. So what can you do? Well, you can do a lot. I'll just note some of the things. I hope these are the important things. But first thing first, you have to know what you have. Especially in big companies that lived for a long time, you've got a lot of APIs of various kinds, and sometimes you don't know about all of them. Those are the shadow APIs. And sometimes you stop using some APIs. The business is not needed anymore. The UI has changed and is now calling different APIs, but the old APIs were left in place and probably not maintained. A good place for a hacker to step in. You also have to map your data, right? And classify it. Sometimes you want to limit everything. Sometimes there is public information that you don't need to limit, but maybe you do want to rate limit it, just not to be bombarded by millions of requests. So first of all, know what you have. Second, define your standardization, right? Because when you start having hundreds and thousands of APIs, you have a problem. You cannot apply automatic tool easily because every API is different, and you cannot get automated reports, and all kind of standardization that's missing is giving you a hard time. So define the standards and enforce them. So that's basically the first step. And another basic thing nowadays is encryption. All systems weren't encrypted. Some of them were encrypted, but in older standard. So use zero trust standard, and it's not just a buzzword. Well, it is a buzzword, but you can take something from there, meaning don't trust anyone. Always verify the identity of whoever calls your API, and use the latest TLS because they don't issue those new versions for nothing. 1.3 is faster, it's more secure than 1.2. And don't just let the browser verify the server or the client in case of a connection between services. Do it two ways. Use mutual TLS for authentication. Don't do general APIs. They expose too much data. If your users don't need to get all customers, for example, give them a more specific API. It's more secure. GraphQL, it's now getting very common. In default, there are some security problems. For example, introspection is allowed, and I can show it to you. This is how it looks like. It's the description of all the objects that you can send to the GraphQL endpoint. And if you're not aware of GraphQL, I'll just say that it's a protocol for queries that exposes one endpoint and let the client describe the query and the objects it wants to get back. So if you can see my screen, this is the introspection of GitHub. All the objects, all the repositories, all the subject objects, and the queries you can run. Very revealing, and in their case, it's on purpose, but I'm not sure that your company wants to expose all of their business object standards to everyone. So block it in production, although it helps in development. You don't want it in production. Add authorization, because by default, there is none. And be careful about deep requests, because in GraphQL, you can define a recursive query, and it's not blocked by default. The depth of the recursion is not blocked. And take a look at that. Again, using GitHub API, GraphQL API, you can query for a repository all of its users, contributors, and others. And for each contributor, you can query his own repositories, and so on and so forth. And you can see on the right side that even after 4 rounds of recursion, 4 levels, you will get back up to 6 million objects, which is a lot. Think about adding 2 more levels and you reach many more, hundreds of millions of objects, and this can cause the server to slow down enormously. And don't worry, they've already blocked it, but check your own queries and endpoints because it's very common. Things change, we all know that, and we mentioned shadow and zombie APIs. So keep a close track, right? In our workplace, we do automatic periodic checks, and the owner has to sign off for every user that has access. And this helps to keep everything up to date. And sometimes you can even throw away old APIs and use more specific APIs, like I've mentioned before. Even if you have everything in place, someone can attack you even without special permission. I've brought this example because it's very impressive. 2.3 terabits per second. That's a lot even for AWS, and it caused them a lot of issues. So user rate limiting, either a device, either a service, you can use WAF or an API gateway, anything that can limit the number of calls. You can do it by IP, by user, by everything you want. And a note about CORS, don't have a lot of time, so I'll just state briefly. CORS is a mechanism that disables the browser from calling a server that's in a different domain than the one of the page that the browser uploaded. Meaning, if I'm coming from, let's say, www.nba.com, I cannot call CNN.com unless the CNN server allows it to me. The problem is that during development, to make things easier, many developers allow this course for everyone. They use a star to allow every browser to call any server. But if this goes to production, it's a problem. And think about, for example, AliExpress, huge Chinese website, millions of users, and let's say that there are just million browsers open concurrently. They can inject malicious code that pings their biggest competitor, Amazon, and sends queries and orders and other stuff to overload AWS servers, and it can be very painful. So notice your CORS definition. OWASP. In case you don't know about OWASP, it's an organization that maps and tracks the security vulnerabilities in various areas, and they have a list specifically for APIs. So take a look at the top 10 and notice the first three. Object level authorization means, I don't have enough time to demo it, but it means that for an object, for example, an order, a user that can read an order, and that's okay, can also modify it, which is not allowed. Meaning that the specific actions are not authorized or defined, configured properly, which introduce leaks. And this is like the most common thing in OWASP last year. So check out this website and you'll know what are the most important vulnerabilities you need to look at. I think almost everyone is using tokens right now, but just one word. Today, it considers safer to use opaque tokens. So that's because JWT is encoded, but it's encoded in base 64, which anyone can decipher. And if you have some secret information in your payload, use opaque tokens. And if you have large payload, use opaque tokens, because this string that no one can read, it's encrypted. It's not the actual payload, it's just a key to the actual payload that's in the database. And another advantage is that you can revoke opaque tokens immediately, as opposed to JWT that has some time to live before it expires. Quickly about payload challenges. Even if you have your permissions set right and your rate limiting and everything seems okay, malicious callers can still use the payload to cause you troubles. It can be very large payload that will stack your server. It can be SQL injection code that will ruin your database. Some evil information that may damage the integrity of your data or introduce some ridiculous results if you haven't created proper checks. Also, large attachments should be avoided and viruses should be scanned for. These are all measures that you can take easily nowadays, and it's important to do so for every APIs with a large payload. Let me skip that, talk about monitoring for a second. Always monitor your stuff, always log all the calls, who called what answer did they get. It will help you when things go wrong to do some investigations and know your protocol for that. What about API gateways? They can do a lot for you. They can rate limit, they can scan, they can do other stuff, they can enforce standards. But remember that many attackers are coming from inside your organization, so no one guarantees that they won't go straight to your microservice instead of going through the API gateway. So protect yourself. You can even put two API gateways and do what's called API firewalling. Put one API gateway inside, one inside a DMZ, split the checks between them, and ease the burden on your internal API and catch some of the attacks outside. There are a lot of tools that can help you. I have named only a few here. Just one thing to note from this slide. If you're not an expert in penetration test, call the expert, order a professional penetration test. You should do all the stuff that you can do in your code. You should test what you can. But if you're not an expert, call the expert. It's safer. So these are the key takeaways. Follow the latest threats through OWASP. Narrow the attack surface by removing old and unused APIs and use more specific APIs. Use all the defenses that are needed. Consult the OWASP for that and do professional penetration test. And at the end, do it again. Last words about the future of APIs. We're going to see in the following years more machine learning based tools and dynamic defenses. Those tools will learn the behavior of your network and alert if there are any anomalies and even defend dynamically for you. There will be more automation for standardization and standard enforcement. And you've known DevOps and now GitOps. Nowadays, we're talking about API Ops, all the set of tools and framework that will help you deploy your APIs and check them in one seamless flow, automated, of course. Besides security, API is going to change a little bit. They're going to be more conversational APIs, stuff like ChatGPT that will preserve context and can talk to you in a more business or human kind of interaction. There will be more streaming APIs instead of the common request response. You're going to have a request and then maybe many responses. And check out Enter.io, a new startup I encountered. They're doing very nice and innovating thing with APIs. Instead of checking the database for business information and collect data from there, they're doing it from the API side, which makes more sense because this is the business interface and they extract a lot of business information from those APIs. I think this is also going to be a big part of APIs in the future. That's it. Thank you for listening to me. And if you have any questions, you can contact me here or later via LinkedIn or my email.